Okay, and welcome back to section 1.4 using the definitions of the trig functions. So in this lesson, the objective is for you to use the Pythagorean identities to solve trig problems and to find other trig function values given one value and the quadrant in which the angle is in. Now keep in mind at this point we're using the coordinate plane and we're using angles on the coordinate plane, and the hypotenuse of these are all 90-degree angles, and the hypotenuse on these is going to be uh, the radius of a circle. So I want you to take a few minutes here. This is really not bell work. Take a few minutes here to put these on a card. Again, if I tell you to put something on a note card, that will be allowed on a test. Your notes are not allowed on a test, so that you'll just go through and write these down. You do have to have these eventually memorized. The idea that sine is the reciprocal of cosecant, cosine and secant are reciprocals, tangent and cotangent are reciprocals. Okay, so the very first problem says to use the appropriate reciprocal identity to find each function value. Rationalize your denominators when applicable. Since we know secant and cosecant, these two guys here are reciprocals, then we know if cosine of theta is 5/8, secant of theta is 8/5. Nothing more to it than that. Okay. So then they hide another one down here for you to work with. And then they have sine and cosecant. And guess what? Sine and cosecant are reciprocals. So if cosecant of theta equals the square root of 24/3, then sine of theta must be 3 over square root of 24. Now the problem did tell you to, or the instructions did tell you to rationalize your denominator. So there's that shortcut you can use, and for those of you who haven't remembered the shortcut, you're multiplying square root of 24 square root of 24 over square root of 24. So this gives us 3 square root of 24 over 24. And this is an acceptable answer. I do want to throw that out there. This is an acceptable answer. However, we can reduce what's under the radical, and we can reduce what's outside the radical. 3 goes into 24 8 times, so I have the square root of 24/8. And this one here, 24, is the square root of 4 times the square root of 6 all over 8, which gives us 2 square root of 6/8, or square root of 6/4. Now this is the more appropriate answer. I'm going to throw that out there. However, since they started the problem with this, I'm okay with this being your answer. You should get in the habit of reducing at least the 3 over 24 and giving me this answer. But I'm okay with this one, that's why I squared it. Okay, next problem. Explain what is wrong with the following item that appears on a trigonometry test. Find secant of theta given that cosine of theta is 3/2. Now this is where I get to go through and recall that secant and cosine are reciprocals. So if cosine is 3/2, secant should be 2/3. But this is a false statement. Cosine of theta cannot equal 3/2. And even ask you, explain what is wrong with the following item on a test. What is wrong is that the range, the values of y for cosine, range of cosine of theta is -1 to 1. And 3/2 is greater than 1, therefore not in the range. And that is what's wrong with that problem. And if 3 over 2 is not in the range for cosine, 2 over 3 will not be in the range for secant. Okay, we may have to go over that one a little bit more, but we'll do it. Okay, next problem. Determine the signs of the trig function of an angle in standard position with the given measure. Determine the signs of the trig function. So they just want to know the signs, no values, just the signs. So what we're going to do is we're going to draw a grid. Well, coordinate plane of some sort here. Okay, and we have a negative 15-degree angle. Negative 15 is going to be down here somewhere. Okay, it's down here somewhere. And so at this point here, what we can claim is going, well, x is positive, and over here, x's are negative, y is positive, and down here, y is negative. Now, there's two things you can use in section 1.3. I told you about positive and negatives on the cosine. All students take calculus. So we're going to use that idea of all students, which means sine, take, we're referring to tangent, calculus, we're referring to cosine. So down here, now remember the question was, where are my trig functions positive? They're all positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, cosine is positive in tangent in quadrant 4. So in cosine of theta, or negative 15 degrees if you want, and secant, because they're reciprocals, are positive, and the other four, and I'm okay with this, the other four are negative. Now, you might get a teacher or somebody later on that's, no, cosine and secant are positive, and then they'll want you to write down tangent and cotangent, secant, cosecant, and sine are all negative. But I think I get the idea, you get the idea of what you're doing. You're just identifying what's positive and then take care of everybody else. Okay, the next one, draw myself another grid. 705, but it's a negative angle. So I know 720 is 2 rotations, and after you guys did enough of section 1.1, I hope you get there as well. So if I add 720, I'm going to get a positive 15 degrees, which means my angle is over here. And this is in quadrant 1. And in quadrant 1, all trig functions are positive. There we go. This is very, very important that you know this, that I can give you an angle. You're going to be able to identify what quadrant it's in and if it's positive or negative. This is extremely, extremely important that you are able to do this. Okay, I was going to use this, but let's go ahead. That way you have it in your notes, but I think I took it out of the worksheet. This is the all. So all 6 trig functions. Students, so sine. This one is tangent. And then cosine. But please don't forget the reciprocals. This means cosecant as well. This one means cotangent as well. And this one means secant as well. Are positive in these. So where are my trig functions positive? And then you're going to go through them going, they're all positive here in quadrant 1. Sine and cosecant are in quadrant 2. Tangent and cotangent in quadrant 3. And cosine and secant in quadrant 4. This probably wouldn't hurt for you to put this one on a card as well. So I'm going to write it up here, note card. You'll eventually not need it, but until then, it's not going to hurt. Okay, so this one here, identify the quadrant or possible quadrants of an angle theta that satisfies the given condition. So on this one here, cosine is positive and secant is positive. So we're going to draw our little grid here, put them here. Okay, and it wants cosine to be positive. Greater than 0 means positive. So it could be here. Cosine's not positive here, so I'm not here. Cosine is not positive here, so we're going to scratch him out. But he is positive here. And I want secant to be positive as well. Well, everybody's positive here, and cosine and secant are reciprocals. He's positive here. So this angle, theta, could be in quadrant 1 or quadrant 4. Again, this is the stuff off the last page. You're going, oh, cosine, where's cosine positive? Here and here, so it can't be in these two. Secant is positive in both of those two, so I can be in either or. Anyways, to know where you're at, they would have to give you more information. Number 40, it's asking the same question. So if you want to pause this to see if you can do it on your own and then come back and check, that would be fantastic. Okay, so I paused, give you time to pause, blah, blah, blah. Okay, this time they want cotangent to be less than 0 or negative. Well, everybody's positive here, so we're going to scratch him out because he's not positive here. But tangent is positive down here as well, and I don't want it when he's positive. So I know it's not in one of these two. I do need to throw this out there. Hopefully you caught on to this. There are 2 quadrants that each trig function is positive, and 2 that they're negative in. So do keep that one in mind. Now this one, they want secant also to be less than 0. So it's okay, we've already crossed out this one. Secant is less than 0 wherever secant's not positive. And from this one, we know secant's positive in 1 and 4, which means my angle cannot be here either. So theta is in quadrant 2. Okay, now you could have also looked at it another way of marking the angle, the quadrant it could be in. So you could have gone, oh, it could be here, or it could be here. Oh, it could be here, and identify it that way. Either way. I like to go in there and just identify, well, it can be in 1 or 4. I'm looking at 32. It can be in 1 or 4, so I cross out the 2 that it can't be in, and then go from there. Okay, last question on this page. Explain why there is no angle theta that satisfies tangent is greater than 0. At the same time, cotangent is less than 0. Now, I would like you to pause this one and think about it for a second. See if you can come up with an answer, even if you don't write it down, and then go there. Okay, so the reason there is no such angle is because tangent and cotangent are reciprocals. And therefore, that is the therefore sign, and therefore will carry the same sign. Anyways, if one is positive, the other one is positive. If one is negative, the other one is negative. They cannot have different signs on the same angle. Okay, this one here, decide whether each statement is possible or impossible for an angle theta. Well, maybe I should tell you the range on everything. Sine and cosine. The range, anyways, the values that they can have is -1 to 1. Tangent and cotangent, the range is all real numbers. So -infinity to infinity. Anyways, any number. Secant and cosecant, because they're reciprocals of sine and cosine, have to have the opposite range. So theirs is -infinity to -1. It is included. Union that with 1 to infinity. So they take what secant and cosecant take whatever value sine and cosine don't take. So the question is, can sine of theta be 3? No. So this is not possible. Can cosecant of theta be -100? Absolutely. That's -infinity to -1. -100 falls in there. This one is possible. You do need to have these. If you want to throw them on a note card, throw them on a note card. You do have to know these. Okay, on this one here, take a moment to put these identities on your note card. You're going to pause this anyway, so I'm going to throw this out there. It says, show that each identity is equal to the Pythagorean theorem. Hopefully somebody will remind me, but we will do this tomorrow in class and talk about the identity, because I know in the homework, at least one of the problems asks you to prove one. And so we'll do the other one in class. Back to Pythagorean identities. Went too far. Sine squared of theta plus cosine squared of theta equals 1. You have to know this one. You have to have this in your head. You have to know sine squared of any angle plus cosine squared of the same angle will give you 1. The other two can actually be got, you can actually get it from the sine squared plus cosine squared, and that's the proofs that we'll be playing with. You don't have to have these memorized. You just have to know that tangent and secant go together and cotangent and cosecant go together. That's what you need to have on those. Your quotient identities, again, put these on your card, your note card. The quotient identity, sine of theta over cosine of theta equals tangent of theta. Cosine of theta over sine of theta equals cotangent of theta. Show that each identity is true. We're not going to play with those. We're not even going, even in class, we're not going to play with those. The other ones are a little bit easier, and besides, if you forget that identity, it's easy to use the Pythagorean to get to it. But this one, it's you know it or you don't. Okay, I was going to stop there, but I've only taken up 14 minutes, and we don't have that much left to do. So, use identities to solve each of the following. Find cosine of theta given that sine of theta is 3 over 5, and theta is in quadrant 2. They gave you lots of information here. So if I draw this out, it's called the grid. Here we go, the grid, the grid. We know that sine is 3 over 5, and we're in quadrant 2. We do know that. So we're over here somewhere. You do not have to have this to scale. And I'm also going to put in the little dotted line here because I'm just wanting to close off my triangle. That way you guys can see it. Now remember, sine is y over r. So my y value, there's y, my y value is 3. My r value, which is the radius, if I drew a circle in here, it would be my radius, is 5. What we need is, what is my x value? And we know because we're over here, my x will be negative. So we use the Pythagorean theorem, and what we're going to, because we're looking for sine and cosine, we're going to specifically use that one, but we're going to use it anyways. But we know that what we have down is x squared plus y squared equals r squared. I want you to go back to a triangle. This would be equivalent of your A, this would be the equivalent of your B, altitude, base, And the hypotenuse is the equivalent of the radius of the circle if we drew a circle in there. So we can put it into format of the x squared plus y squared equals r squared. So we don't know x. We know that y is 3. So we have 3 squared plus, we don't, yeah, did you guys catch that? Try it again. We don't know x, so x squared plus y, which is 3 squared, equals r, or 5 squared. So x squared plus 9 equals 25. X squared equals 16. I just subtracted 9 from both sides. So x equals plus or minus 4. Got to square root both sides. So x squared equals square root of 16. That gives me plus or minus 4. But because I want a negative x, there it is, I want the negative version. So x equals negative 4. And cosine of theta equals x over r, so we get an answer of negative 4 over 5. Now, one of the things I do want to throw out there to you guys is Pythagorean triples. There are certain ones that are very, 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 very popular. 3, 4, 5 is the most popular. Know this one. I'm going to throw that out there. Know this one because this is one that you'll see a lot. At the end where it has the homework, I'll write out, I think there's 3 others that I know off the top of my head that I'll write up there. There are many, many, many more. Okay, next question. Find tangent given that sine is 1 over 2 and theta is in quadrant 2. So we're in quadrant 2 again. So, I don't want that. I want the straight line, the solid line. And I'm going to just draw out the triangle and I'm going to close it out with a dotted line. Do the same thing. Remember, this is y over r. So y is 1, r is 2, this is negative x, and we're looking for x again. So you might want to pause this, try this out yourself. But remember, tangent, we're going to throw this to the side. Tangent of theta is y over x, so we do need x. So on this one here, x squared plus y squared equals r squared. Don't know x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. So x squared equals 3. Square root both sides. And we get x equals plus or minus radical 3. But we want the negative version of that. So now we can come over to our answer. It's y over x. Y is 1 over negative radical 3. But they do tell you to rationalize your denominator. So tangent of theta, this is why I'm going to do the shortcut on you guys. Remember, leave the 1, bring this whole thing up, so negative radical 3, all over, and then just take what's on the inside, 3. So you get an answer of negative radical 3 over 3. And there you guys have it. Okay, I do believe this is the last one. Okay, and I know I'm a little over 20 minutes, but we're doing okay. Okay, find the 5 remaining trig function values of angle theta if sine of theta is radical 2 over 6, given that cosine is negative. So I do want to throw this out there. They want sine of theta, which is radical 2 over 6, cosine of theta, which all you know right now is going to be negative, and tangent of theta. But they also want cosecant of theta. But guess what? You already know it because you know sine. So this is going to be 6 over radical 2, and we will have to fix that. Secant of theta, because cosine is negative, will also be negative, and cotangent of theta. Now here's the question for you. We have sine and cosecant, which are both positive, cosine and secant, which are both negative. You know tangent and cotangent are going to carry the same sign. Are they positive or negative? I'm going to give you time to think before I tell you that answer. Okay, so this one here, they're telling you that, remember, sine is y over r. So they're telling you that cosine is going to be negative. So we need x, which we know is going to be negative, y, which we know is square root of 2, and r, which we know is 6. So x squared plus y squared equals r squared. So x squared plus square root of 2 squared equals 6 squared. So x squared plus 2 equals 36. So x squared equals 34. So x equals plus or minus square root of 34. But we know we want the negative square root of 34. Now I'm going to throw the, no, we cannot reduce this any more than that. The only thing I want to throw out there is I didn't have to decide because I was told here cosine was going to be less than 0. So remember, cosine is x over r. So this is negative square root of 34 over 6. And so this guy here is going to be 6 over square root of 34. And then tangent is y over x. Have you guys decided if it's positive or negative or not? If you remembered from one of the previous lessons, I had already told you 2 positive, 4 negatives. If one is negative, you're going to have 4 negatives. This guy's going to be negative. Y over x is going to give you square root of 2 over the square root of 34, but it's negative. Now, radicals you can reduce. Radical over radical, you're really going to get negative 1 over the square root of 17, because 2 goes into 34 17 times. And then if I flip this guy over, I get negative radical 17. Okay, I still have 3. If you got this far, if you paused and got this far, you're in good shape. So, but these we have to clean up. So I'm going to change colors to clean it up. Okay, so remember, you bring the radical up. So this is 6 radical 2 over 2, which will clean up to 3 radical 2. Same thing with this one. This is going to go negative 6 radical 34 over 34. But this is going to clean up to negative 3 radical 34 over 17. By the way, I'd be happy with this one. And this one here is going to become negative radical 17 over 17. And we didn't have to do anything more to that because we cleaned them up here. Okay, so we are done with those. And I believe that was the last problem you guys had. So lots of answers going on here. This is the only one that they gave you. So you had to come up with this one as well, and this one as well. Okay, homework page. There's your homework. Yay, raw. Okay, here's the thing that I do want to throw on there to you guys. As I told you, I give you Pythagorean triples. Now, these are not the only ones that are out there. These are the ones that are most common. Your 3, 4, 5, and any multiple of it. You have a 5, 12, 13, 8, 15, 17, and 7, 24, 25. These are the most common ones that are used. Put them on a note card. That's going to be just fine if you want to put them on a note card. Good luck on the homework.